graph, and we actually write down every month, and we made a first is the initial payment. This is the interest rate, 7.5. This is what we'll be paying every month. And the yellow is the yearly, is how much you're gonna be paying yearly. This is how much you're gonna pay. These two graphs, they represent the different amount of money you're gonna pay monthly. This is $1,398.43, and here you're gonna pay $1,611.19. In this graph, we can actually see that both of these are constants, and we're actually gonna finish paying earlier when we pay more money monthly. You can see in the graph here, when you pay $1,398.43, you're gonna be paying the loan of $200,000 in 30 years. And when you pay $1,611.19, you're gonna be finishing in about 20 years or so. What else?
So the less you pay, the longer you take to finish paying your loan. And in these graphs, we are representing both different payments. This graph is the one that finished faster, which is the one where you were paying $1,611. And this other chart is the one that took longer to finish. To finish paying, which is the one that paid monthly $1,398.43.
The total payment in this one is $504,000 approximately, and in the other you pay much more less than that. You pay $300,000, so it's a considerably amount. What we did in this table was basically the formula for this was so the formula, this is the initial payment. The loan was $200,000, and so we just multiply by the interest rate and divide it by 12 because the interest rate is yearly, and we sum this up, subtract this, and we just get the number. And this is the final pay, the amount you have to pay for the next month. And so it goes. So it's better to pay more monthly, so you can you pay less in the end, basically.
You pay less interest.
On question D, they ask us to find the instantaneous rates of change of t with respect to x when x equals 1,398.43 and when x equals 1,611.19. Here what we need to do is first, we need to derivate the equation that they give us there. So the equation that they give us is t equals 30.375 natural logarithm of x over x minus 1,250. Remember the rules from first semester? Well, that's what we're gonna do here. For everything that is dividing, is gonna pass subtracting. So 30.375 natural logarithm times x minus 1,250 minus, because it's dividing, 30.375 natural logarithm of x. Then we're gonna multiply. Then we're gonna find the derivative. The derivative of natural logarithm is u prime over u. So 30.375 times u prime of x minus 1250 is 1 over x minus 1250 minus 30.375 times u over u times u prime over u. That is, derivative of x is 1 over u, that is x. The next thing we're gonna do is we're gonna multiply. So we're gonna multiply 30.375 times 1 over x minus 1250 minus 30.375 times 1 over x. And the next thing we're gonna do is we're gonna subtract those two by getting a common denominator. So our common denominator is gonna be x minus 1250 and x. So we're gonna multiply 30.375 times x, because it's the common denominator you're missing, and it's 30.375x, and then we're gonna multiply 30.375 times x times 1250. So that's gonna give me minus 30.375x plus 16,718.75. So that's how we get our derivative. Our derivative is 16,718.75 over x minus 1250 times x. That's our derivative. So when we get our derivative, the last thing we need to do is we need to place the values of x inside our equation. So when x equals 1398.43, then our answer, let's see what will be. So 16,718.75 over 1398.43 minus 1250 times 1398.43. You put that on the calculator and it gives you an answer of 0.080. And when x equals 1611.19, then let's see what will it give us. Is 16,718.75 over 1611.19 minus 1250 times 1611.19. We put that on the calculator and it gives us an answer of 0.028. So, the instantaneous rate of changes when x equals 1398.43 is 0.080, and when x equals 1611.19, it is 0.028.
In this problem, we had to analyze what would be better for a person that wants to ask for a loan of $200,000, to pay $1,398.43 every month with an interest of 7.5%, or to pay $1,611.19 every month with the same interest. We had to make a deep investigation in how we could take the information to do this very precise. What we did was to use an Excel sheet and put all the values that we had. We constructed a sheet where it showed us monthly how the numbers of the payments were. Both charts started in the 1st of January 2016 and ended differently. The first chart that we had, that was that they pay less money per month, finished paying all his loan with interest on the 1st of November of 2045. On the other hand, the second chart, the one that is paying more a month, finished paying all their loans and interest on the 1st of November of 2035. The results that we could conclude were that the final payments of the first charts were of $504,833.23, while the second chart of the final payment was of $386,685.60. This means that at the end of the second chart pays less money than the first one. The results gathered were the second chart, the one that is paying more money per month, was the best option since you pay less interest and in a shorter amount of time.